Good morning, students. Today I want to explain about an important thing in polynomials, that is division algorithm in polynomials. So, division algorithm of polynomials, in first chapter we have learnt about Euclid division lemma, division algorithm of real numbers. Division is division for either real numbers or polynomials. Dividend, divisor, quotient and remainder will be the same. But in polynomials, those things will be polynomials. That's the difference. Real numbers will have the real numbers and polynomials will have the polynomials. For example, we'll have a division in previously with real number 7 with 2, 2 3s are 6 and remainder is 1. So here we can say that 7 is dividend and 2 is divisor and 3 is quotient and 1 is remainder. So we will apply that division lemma. We will say that 7 is equals to 2 into 3 plus 1. So this is division algorithm for real numbers. In place of real numbers, we will use now polynomials. That's the difference. Everything is remaining is same. So we'll say how it is. It is nothing but we have to take some polynomials. One is p of x and another one is g of x. Two polynomials and g of x should not be equal to 0. Then we can find polynomials q of x and r of x such that p of x is equal to g of x into q of x plus r of x. I will explain you with the division the same. So p of x will be the dividend here. This is a polynomial which to be divided. So with what we have to divide? G of x. This will be the divisor. And we will get some quotient when dividing these polynomials. That quotient will be taken as q of x. And after completion of division, we will remind with some reminder that is nothing but r of x. So p of x is divided with g of x and quotient is q of x and remainder is r of x. So here we have to take care about that conditions for the things. First thing is g of x not equal to 0. That means divisor must not equal to 0. Divisor never equals to 0. And q of x and r of x will be the polynomials by getting the division. So now we'll apply, see the conditions, and with an example also we can see the division. So if you go with the conditions for r of x should be 0 or degree of r of x is less than degree of g of x if r of x is not equal to 0. So the same what we have do in the division of real numbers. Remainder is 0, a remainder should be less than the divisor. So there we have to stop the division. We will get 0, we can stop the division, or if we get a remainder, the degree of a remainder is less than the degree of the divisor, then you can stop the division. That we will see with examples. Some observations we will have, some things we have to remember here. The first one is, if g of x is a linear polynomial, then r of x is always a constant. That means linear polynomial we have done with the previous video. What is a linear polynomial? The first degree polynomial is said to be linear polynomial. So if you are dividing a divisor, a polynomial, dividend polynomial with a linear polynomial, then you will get the remainder as constant. And second observation what you have done is, if degree of q of x is 1, then the degree of p of x will be 1 plus degree of g of x. So if the quotient degree is 1, then how will you get the degree of dividend? It's nothing but degree of divisor plus 1. And then if the p of x is divided by x minus a, then the remainder is p of a. It is nothing but a remainder theorem. This we will apply in finding the values. So if we are dividing p of x with a divisor x minus a, it is nothing but substituting a in the place of x, you will get the remainder, not quotient, remainder. And one more, if r equal to 0, remainder equals 0, what we'll say in real numbers? That is a factor. Similarly, we can say that if r of x is equals to 0, then q of x is divides p of x exactly, or q of x is a factor of p of x. We'll observe all these conditions with an example of division. Once you see this, divide f of x is equals to 14x cube minus 5x square plus 9x minus 1 by 2x minus 1. Now, this is the thing. Here 14x cube minus 5x square plus 9x minus 1 with the dividend and 2x minus 1 will be the divisor. Here one thing you have to remember, first you have to arrange all these terms in the descending powers of x. So first third degree, second degree, first degree, 0. Okay? You have to arrange them in the descending powers of x. That's the thing first you have to remember. If you don't have any power term there, for example, if you have 14x cube and if you don't have the 5x square, then you have to keep here 0x square. So every time you have to arrange them in descending powers of x. Similarly, you have to arrange the divisor also in the descending powers of x. We cannot write this one as 1 minus 2x. You have to start with 2x minus 1. And the first step what you have to do is 14x cube, this term, and divided by 2x, first term. Once you observe, this is the 14x cube first term of the dividend and first term of the divisor. If you divide the first term of the dividend by first term of the divisor, you will get 2 cancelled in 14 7 times x in x square. That will be the first term of the quotient. So if you multiply now 2x into 7x square, you will get 14x cube, and that 2x, that 7x square into minus 1, you will get minus 7x square. Now we have to subtract as in previous division. So subtracting the things, the symbols will be changed. So plus 14x cube becomes minus 14x cube, minus 7 becomes plus. Then what you will get after doing this, 14x cube minus 14x cube will be cancelled. Minus 5x square plus 7x square gives us 2x square, and we take down 9x. Now the next step is the first term of the thing here, dividend 2x square, by the first term of the divisor again. 2x square by 2x, you will get x. That x will be the second term in the quotient, and you have to multiply with x into this divisor. X into 2x becomes 2x square, and x into minus 1 becomes minus x. That you have to write under this. Now again you have to subtract. After subtracting, what you will get, 2x square and minus 2x square will be cancelled, and 9x plus x becomes 10x, and we will take down minus 1, 2 down. So then again the next step what you have to do, the first term in the dividend 10x should be divided with 2x, first term of the divisor. So 10x by 2x you will get 5. That will be the third term in the quotient. So if you multiply 5 into 2x minus 1, you will get 5 into 2x 10x, and 5 into minus 1 is minus 5. Now again you have to subtract the things. So 10x minus 10x will be 0. Minus 1 plus 5 gives us the 4 as the remainder. Now we'll see what we have discussed in the first condition. See the first one, if the q of x is a linear polynomial, see the degree of this polynomial is 1. So this is linear. So what is the remainder? Remainder is constant. We got that. And second one is, see that degree of the quotient is 2. Degree of the divisor is 1. So what is the degree of the dividend? 2 plus 1, 3. So degree of the dividend always equals to degree of the quotient plus degree of the divisor. And one more important thing what you have to see here is where I have to stop the division. Generally in the number system we can see that division we can stop by observing the numbers. For example, if I go with some 17 divides with 3, I cannot go with 4 times. I will go with 5 times, and that is the maximum. 3 5s are 15, and the remainder is 2. I will stop the division here itself. Why? Because the 2 is less than the number 3. So we'll stop the division in numbers until we get a lesser number than the divisor. The same we will apply here, where we will have some confusion here, that where we have to stop the division in polynomials. That's the same thing. What is the degree of the divisor here? 1. So you can stop the division until you get a degree less than that, not the number, degree. Here degree is 1 linear polynomial. Degree of constant is 0. So I have to complete the division until I get a term which has the lesser degree than the divisor. These are the things we have to keep in our mind of division of a polynomial You can practice some more examples and I will give you some non-routine problems even on the division. Wish you good luck. Thank you. In next video, I will explain how to verify the division algorithm and some more problems in division of polynomials. Thank you.